situation where the amount that we produce, which is output, is equal to the amount that we are spending on that output. So if we refer to this side of the equation as aggregate expenditure, what we're interested in is a situation where output Y is equal to aggregate expenditure. Why are we in, or where does this come from? What is the relationship to what we've covered before? What we saw in the previous chapters was that output, our GDP over time, fluctuates, goes up and down. Even if over time it's increasing, that trend is not a smooth upward trend. It jumps up and down along the way. And one of the questions was, why does it do that? One of the sort of big issues in the 1930s during the development of economic theory that we're discussing was, why does this thing jump up and down? And what happens if it jumps really, really far down? Like, what do we do to make it go up? And also, why is it that it has jumped really, really far down? And the suggestion was that it has to do with an imbalance in the adjustment mechanism in the economy. Now, you know, from microeconomics, your usual adjustment mechanism, in other words, the difference between, say, the quantity demanded of something and the quantity supplied, if there's any difference, then what happens is the price adjusts and it brings those quantities in line. Okay? So if we're treating the trend line as potential GDP, in other words, that's the amount of output we can produce, why would we ever produce some amount that was different to the amount we could produce? Why do we have unemployed labor? Why do we have capital that's not being used? So the suggestion was, well, maybe the adjustment mechanism which comes through prices, there's something wrong with that adjustment mechanism. And the terminology used was that prices are sticky. In other words, the prices are not adjusting the way they should adjust. So this model was then based on the idea that if prices were sticky, how might output adjust? So our Keynesian model, which distinguishes between expenditure and output and focuses on the expenditure side, said, let's look at each of these components of expenditure and focus specifically on consumption, and let's break consumption up into let's make consumption a function of output itself, in other words, income. Consumption is a function of income, and we rearrange our equation. What we can do is we can plot our level of expenditure, so this is consumption expenditure, and when we combine it with our other consumption variables, we have an upward sloping aggregate expenditure function. And if we plot aggregate expenditure against output, or against income, we have an upward sloping aggregate expenditure function. And this function, the slope of this function is less than 1 because it's determined by the propensity to consume. And it'll only actually intersect a 45-degree line. In other words, aggregate expenditure will only equal output or income at one point on that aggregate expenditure line. In other words, only at one point will the amount that we produce correspond to the amount that we are actually prepared to consume if prices are fixed. At that point, our economy would be in equilibrium. We would have no unemployment. We would have no unused capital. At any other point along this curve, we might well have unused capital or unemployment. And the question was, well, can the economy in any way adjust if we are not at this point? And the theory, the model suggests that yes, the economy will adjust. Why? Because if we're anywhere other than equilibrium, and in this table where we look at various points along that aggregate expenditure curve, our equilibrium, in other words, the point where output equals the sum of all these other columns, which is aggregate expenditure. The point where output equals aggregate expenditure occurs when output, the value of output is 13 and the value of aggregate expenditure is 13. So this level here, given by point E, is our equilibrium. At any other level, what we have is either output is less than aggregate expenditure, like a point D, or that output is greater than aggregate expenditure, like point F. And what we find is if we're at point D, for example, firms will have an unintended buildup unintended reduction in inventory. An amount of 12 has been produced, but an amount of 12.5 has been consumed. The only way that could have happened is if that extra 0.5 that was consumed was from production that happened in a different period. In other words, it was consumed by allowing firms to draw down on their inventory. If firms are drawing down on their inventory in an unexpected way, that is a signal for them to increase output. So we would move naturally from point D to point E. Alternatively, if we're at point F and we're producing 14, but people are only buying and consuming 13.5, what is going to happen is that firms are going to have an unintended buildup of inventory. In other words, they produced some output which they wanted to sell, they weren't able to sell it, their inventories increase by some unintended amount. That's a signal to firms to reduce their production. So we move from point F to point E. And hence what happens is our economy converges on this equilibrium point E. So if we're anywhere to the left of this point, or if we're anywhere to the right of this equilibrium point, our economy naturally converges to that point D. Okay, so even without prices changing, we can have conversion, right? The concern was that for that conversion to happen, it takes a long time, right, for firms to adjust inventories. And in the meantime, we are not at full employment, and that's potentially a problem. So the question was, is there any way we can basically speed up this process? The answer that was presented was yes, through government spending. Government can get involved to make a difference here. We haven't gone into that answer, but we will in chapter 28 or chapter 29, I can't remember exactly. But when we deal with fiscal policy, then we'll see how it is that government can move us back towards equilibrium and can do it much quicker than, say, firms could. And why, therefore, government intervention is potentially a good way to get our economy back to equilibrium if we've moved away from equilibrium. So we basically just spent a lot of time deriving this model, talking about its mechanics, how it works. We introduced something called the multiplier. What the multiplier means is that even though I shift my curve up by a small amount, in other words, I change the level of aggregate expenditure by a small amount, the autonomous level. So if I shift my intercept on the y-axis, if I shift this intercept up by a small amount, I end up moving the equilibrium point by a large amount so that my actual change in GDP is much larger than the upward shift in the aggregate expenditure curve. So a small increase in autonomous expenditure leads to a large increase in output. This was one of the justifications for having government spending involved. A small increase in autonomous government spending leads to a large increase in output due to the multiplier effect. We derived the multiplier effect, and we looked at it both graphically and as an equation mathematically. And then that brought us essentially to this slide here, which is right at the end. We want to finalize our discussion on the multiplier. Then we want to talk about what happens when prices change. Because when prices change, we end up with a relationship between aggregate expenditure, which gives us equilibrium output, and prices. So our discussion up to this point has been with a fixed price. Our conversation then moves to one of asking, what happens when prices change? In other words, what happens if we no longer assume that prices are fixed? Does our model, or is our model able to take into account this additional kind of factor? So the multiplier, what are we referring to? The relationship between the change in autonomous expenditure and the change in output. So if this is our aggregate expenditure model with our 45-degree line, as I just mentioned, if we're anywhere other than this equilibrium point, if we're anywhere to the left of this equilibrium point or anywhere to the right of this equilibrium point, we're essentially talking about business cycle dynamics. Okay? So if we're then plotting, so this is output against aggregate expenditure. If we're plotting output against time, and our trend is potential, then any movement away from potential GDP is a movement away from this equilibrium point. Okay? So essentially what we're dealing with is the business cycle, just in a different diagram. We spoke about fixed prices. What happens when prices change? In other words, when firms cannot keep up with sales and their inventories fall below target, they increase production. That's a movement along this aggregate expenditure curve if we're to the left of equilibrium. Firms could, right, increase production. However, at some point, they also raise prices. In other words, you're producing some amount, you're selling more than what you're producing. Okay? There are two ways in which we can deal with that. We can increase production, or alternatively, if we no longer assume the prices are fixed, we can also raise the prices of the output that we're producing. In the same way, if firms have unwanted inventories piling up, in other words, they have an increase in inventories that was unplanned, we're somewhere to the right of this equilibrium point. Two ways that they can deal with this. First of all, they can decrease production, especially if prices are fixed. If they have no ability to change prices in any way, then they decrease production. Alternatively, so decrease production. Alternatively, they can also cut the prices of what they're selling. If they cut prices, they will sell more. If they're selling more, they will have less of an inventory buildup. Okay? So you can either change quantity or you can change price. That is the kind of environment we're now going to be dealing with. Which brings us to the relationship between aggregate expenditure and aggregate demand. The aggregate expenditure curve is the relationship between aggregate planned expenditure and real GDP. Okay, this is our aggregate expenditure model. The aggregate demand curve, however, is the relationship between the aggregate quantity of goods and services demanded and the price level. In other words, the aggregate demand curve is the relationship between output and price level. So aggregate expenditure curve, the relationship between aggregate expenditure and output, aggregate demand, output, and prices. So you can see that obviously if there's a relationship between output from a demand side, right? In other words, this is output that people want to buy. There's a relationship between output that people are buying and price level, and there's a relationship between the output that people are buying and aggregate expenditure. There must be some sort of relationship between aggregate expenditure and price level. That's what we want to deal with in the next slide. So we're going to derive the aggregate demand curve. In other words, when the price level changes, what we find is that aggregate planned expenditure is going to change, and therefore the quantity of real GDP demanded is going to change. Okay? The aggregate demand curve slopes downwards for two reasons. This is what we're going to talk about right now. I'm just going to zoom in here so we can look at this a little bit better. Here's the story. Imagine we begin, let me make it even bigger. Imagine we begin with some aggregate expenditure level output, aggregate expenditure level AE0, okay? And our price at this point we are going to refer to as P0. Okay? Or let me just do it like this. Put brackets, this is P0. Okay? If I'm at aggregate expenditure level AE0, and my prices are at some level of P0. Okay? what happens if the price level increases? Okay? If the price level increases, there are two effects that we're going to refer to here. A wealth effect and a substitution effect. A wealth effect says that when the price level increases, the current level of your wealth, right? In other words, your wealth as it sits in some kind of, in any kind of nominal value, right? In other words, if you have savings in a bank account, for example, right? When the price level increases, the purchasing power of those savings is going to decrease. In other words, the value of your wealth decreases, right? The amount that your current wealth can purchase decreases because that price level's gone up. Okay? So that's one thing. Alternatively, a substitution effect. What's the substitution effect? For a given price level, for a given future price level, right? A rise in the price level today means that current goods and services are more expensive relative to future goods and services. And that results in people delaying current purchases for intertemporal exchange reasons. In other words, what's going to happen is, assume that the price level goes up today and you think it's a temporary price level change. In other words, we're not assuming that this is an inflationary effect, just the price level has gone up. We're not sure why it's gone up. Maybe it'll come down again. Okay? We're not sitting in an environment where inflation is a given, right? We live in a country, for example, where inflation at about 6-7%, that's normal, right? If you live somewhere in, say, the US, inflation is more like 2%. Okay? What that means, practically, is that the price of something in South Africa doubles roughly every 10 years. In the US, it doubles once every 35 years, right? So if there's a significant price change in something and you notice it, and you're in the US, for example, it's not necessarily clear whether this change in price is an inflationary effect, or if this is just sort of some strange temporary thing that because the economy is not in equilibrium, our prices are changing in a way that we don't expect, and soon the prices will stop changing. Okay? So if the price level jumps suddenly, what we're saying is that current goods now suddenly become more expensive relative to future goods if we don't expect this price jump to be a regular thing, right? So then we say, right, let's rather delay our purchases now, just see what happens, because maybe goods will be a little bit cheaper in the future. Okay? So when the price level increases, there's two reasons that I stop buying goods. One, there's a substitution effect intertemporally. I don't buy now as I wait to see what's going to happen to prices and whether the prices are going to go down, and I'd rather then buy in the future. So my consumption goes down now due to a substitution effect if the price goes up. That was the second thing we discussed. The first thing we discussed, the wealth effect. If the price level goes up now, the real value of my wealth goes down, right? Which means that the real purchasing power, my real consumption that my wealth affords me goes down, right? Now, if you recall, from our consumption function, C equals A plus BY, autonomous consumption is a function of wealth. In other words, the amount that we consume independent of our current income is based on our wealth. If the price level goes up and the real value of our wealth goes down, what happens to our autonomous consumption? The model suggests that our autonomous consumption goes down as well. If the value of A goes down in our aggregate expenditure function, what is decreasing? My y-axis intercept, right? if the value of A decreases, my entire aggregate expenditure curve shifts down. So if prices change from P0 to P1, okay, and what I'm saying here is that P1 is greater than P0, in other words, prices have increased, an increase in prices does what? It shifts my aggregate expenditure curve down. So aggregate expenditure curve AE0 was at price level P0. Aggregate expenditure AE1 is at price level P1. What happens to the equilibrium level of output when we change prices? The equilibrium level of output that we are prepared to purchase. In other words, the output that we demand, right? At P0, our equilibrium level of output was 13. When prices increased to P1, our equilibrium level of output decreased. So what do we have here? We have that an increase in prices, right? So from P0 to P1, an increase in prices does what to the quantity of output, the equilibrium output that we can afford to purchase? It decreases. So if we therefore plot the level of output that is demanded as the price level changes, what we've said here was, for example, at point B, if point B corresponds to price level P0, so we're saying that essentially this price level 110 equals P0. When our price level increases, okay, so our price level increases to say 130, and we say 130 is equal to P1, we move from a point like point B to point A. So point A here is at P1. What happens to our level of output? Our level of output decreases. So when the price level increases, our level of outputs, in other words, the amount that we want to purchase, right? The level of output based on the amount that we want to purchase decreases. So if we think about where we were at point B and we think about it relative to point A, from point B, when prices increase, we move to say this point on a lower aggregate expenditure curve. I'm going to call it point D. At point D, what happens? The level of output that we're producing, 13, is less than the level of aggregate expenditure, somewhere here 12.3 or something, right? So aggregate expenditure at point D is less than output. So what happens at point D? Firms reduce the amount that they are producing. As they reduce their production, we can move along aggregate expenditure curve AE1 from point D towards point A. So the decrease in price leads to a decrease in equilibrium output based on what people are prepared to spend. You happy with that idea? So we move from a point like point B to point A. The other side of the coin is simply the reverse of what we discussed. What happens if the price level changes in such a way that the price level decreases? So let's consider a point like P2. And we say that P2 is less than P0. When the price level decreases, what happens to the real value of our wealth? The real value of our wealth increases. As the price level goes down, any wealth that we have accumulated now purchases more real goods, right? The nominal value of our the nominal value of our wealth remains the same, but prices go down. The real purchasing power of our wealth increases. So when the price level decreases to say P2, our intercept increases. Okay? In other words, our aggregate expenditure curve shifts up. When the aggregate expenditure curve shifts up, we move from point B towards point C. Point C is our new equilibrium at lower prices. Lower prices generate higher output. Okay? In other words, we move from point B towards point C. Okay? As the price level decreases, the level of expenditure increases. Oh, thank you. Awesome. Okay. Any questions with that diagram? Everyone happy with that? I've been asked to spend a lot of time on the diagram. I feel like I've spent a lot of time. Would you like me to spend any more time on the diagram? No. Happy? Okay. So if we've derived our aggregate demand curve from our aggregate expenditure curve, the next question is, for example, what happens if I shift my aggregate expenditure curve, but not because of a change in prices? Right? If my aggregate expenditure shifts because there's been a change in one of the autonomous components of expenditure, in other words, let's say government spending increases, right? An increase in government spending does what to my intercept? It increases my intercept. It shifts my aggregate expenditure curve up, right? If my aggregate expenditure curve shifts up, I get a higher level of equilibrium output. Are you happy with me, with what I'm saying so far? Right? So I now have a higher level of output, but I have not changed the price level. What does that do to my aggregate demand curve? Are you happy that at any given price level, I'm going to have a higher level of equilibrium output? In other words, my aggregate demand curve is going to shift to the right. If I shift my aggregate expenditure curve for any reason other than a change in price, I shift my aggregate demand curve. If I shift my aggregate expenditure curve because my price level changes, then I'm describing a movement along an aggregate demand curve. You got the difference? Change in price level shifts aggregate expenditure, causes a movement along a demand curve. Change in aggregate expenditure not due to change in price shifts aggregate expenditure, which then shifts the entire aggregate demand curve. Okay, so in other words, changes in aggregate expenditure and aggregate demand. When any influence on aggregate planned expenditure other than the price level, both aggregate expenditure and aggregate demand shift. We then finally end up with the diagram such as the following. And it's kind of a little bit of a skip ahead, and it's what you could call a prelude to where we are going. But we know from microeconomics that if you've got downward sloping demand and upward sloping supply, if you shift the demand curve, you have an increase in price level. Not so. Right? When we shift demand, our equilibrium is going to change and we're going to have an increase in prices. So what happens then if aggregate expenditure increases not due to a change in price level? So we shift from AE0, so this is when prices remain at P0, to AE1, where prices remain still at P0. We have an increase in output. We have a shift in the entire demand curve. Okay? We move from point A to point B. What this looks like, and I'm not going to be able to draw it unless I do this a little bit separately. This initial point here was point A. Okay, let me just draw A here, and then I'll move it. So that initial point was point A. When I move from point A to point B, with prices unchanged, I'm moving from point A in my demand-supply environment to this point here, which is point B. But when prices start increasing, which shifts my aggregate demand curve down, an increase in prices shifts aggregate demand down, towards, say, as my prices increase from P0 to P1, I move from point B to point C. That's represented by movement from point B to point C in my demand supply environment. Okay? So we have not yet dealt with aggregate supply. But what we're going to see when we do move into this environment is that any shift in aggregate demand will lead to a change in prices as well. What that means in our aggregate expenditure model is that we're going to have two movements. An increase in an autonomous component of aggregate demand, of aggregate expenditure, shifts our aggregate expenditure curve up. Great. However, that increase in aggregate expenditure leads to a shift in the demand curve. The shift in the demand curve, okay, is going to cause a disequilibrium in our market space once we take supply into account, once we take aggregate supply into account. That shift in the demand curve therefore leads to an increase in prices and an upward movement along this demand curve, which is represented in our aggregate expenditure space as a shift down in the aggregate expenditure curve due to a change in prices. And that is how our aggregate expenditure model eventually fits into our AS-AD model, AS aggregate demand, AD aggregate demand, AS aggregate supply. So what we've done at the end of chapter 7 is essentially derived aggregate demand from aggregate expenditure. Okay? So we've measured output in terms of aggregate expenditure, in terms of a demand side of the economy, and we've taken that aggregate expenditure and derived an aggregate demand curve. We've derived a relationship between prices and quantity demanded. Okay? And that's the end of our chapter 27. Any questions on these diagrams at this point? I'll give you a couple of moments to think about it. Okay, are you guys happy then? We can move away from chapter 27. We're going to move on to then the money stuff in chapter 25. You happy with that? Okay, is it time for a break? It's not really time for a break, but we can take an early break because I think it's a good spot for a break. And then we can move on to money. You guys happy with that? Yeah? Okay, cool. So then what I'm going to do is move on to money today. Next week, Wednesday, when we begin the lecture, I will start with 2 questions. One will be a question on aggregate demand, aggregate supply, and one, well, actually wait, let me get your input. Do you want to do a question now on this, or do you want to do one next week? In other words, would you like to attempt to do a question now based on what we've done, or would you prefer to leave it until next week? Yeah, we can. I mean, we've got time. It's just a question of whether you want to or not. You want to, I'm assuming. Yeah. Do you guys want to just do a quick question then? Just test that you're happy with everything? Okay, cool. Let's do that. So, exactly what we've just discussed, what I would like you to do, get out a piece of paper and a pen. We're going to plot an aggregate expenditure curve. So we've got output Y, aggregate expenditure, AE. We've got some 45-degree line, which gives us all the points of equilibrium between aggregate expenditure and output. In other words, all the points of equilibrium between the X and Y axes. And we've got some level of aggregate expenditure, AE 0. And AE 0 corresponds to some price level P0. In fact, let's do this. AE0 equal to, AE0 is equal to C0 plus I0 plus G0 plus X0 minus M0. Okay? And our equilibrium here is going to be Y0 and AE0. Okay? So that's our setup. What I'm also going to tell you is that this equilibrium level of aggregate expenditure occurs at some price level P0. Okay? here's what I'm going to tell you, or here's the setup for the question. What's going to happen is G is going to increase. Okay, so I'm going to there's going to be some level G1, which is going to be greater than G0. Okay, what I'd like you to do is plot. Okay, and I'm going to call it's going to lead to some level of aggregate expenditure AE1. I'd like you to draw AE1 on your aggregate expenditure diagram, and I would like you to illustrate this change. Illustrate this change. I would also like you to illustrate on your diagram equilibrium. Equilibrium and equilibrium in terms of AE1 and Y1. So there will be some level of output, aggregate expenditure level 1 and output level Y1. Okay, so that will be on your diagram. Then what I want to do is to say that this increase in government spending also leads to an increase in prices, such that price level 1 is greater than price level 0. Okay. What I'd like you to do is then illustrate that as well. Same thing, I'd like you to illustrate the change, and I'd like you to illustrate the new equilibrium. Sorry, this change in price level is going to lead to new aggregate expenditure relationship, AE2, and your new equilibrium levels of aggregate expenditure, AE2, and output, Y2. So following on from our discussion that we've just had, that should be relatively straightforward. If you have any issues, just raise your hand, and I'll help you with that. Otherwise, take 5 minutes. Shouldn't take you long to illustrate exactly what's going on there. I'm going to come and walk around quickly just to see what you guys are doing. Okay, I didn't see anyone having any particular trouble with this, so hopefully that's a good sign. What happens when we have an increase in government spending? Well, our aggregate expenditure curve shifts upwards to AE1, right? Sorry, let me just zoom in a bit. Okay, so we have an upward shift in our aggregate. No, that's a silly place to do it. Hang on. There you go. So we have an upward shift in our aggregate expenditure curve. So our aggregate expenditure curve shifts up. We now have C0 plus I0 plus G1, because our government spending has increased, plus X0 minus M0, and our prices are unchanged at P0. What happens to our level of output? Output increases. Okay. Output increases to output level Y1, and equilibrium aggregate expenditure increases. So we now have AE1. Okay. That was the first part. Second part, our increase in government spending has also generated an increase in prices. The increase in prices does what? To aggregate expenditure, shifts our aggregate expenditure down. So our aggregate expenditure shifts down. So now we have C0 plus C1, 0 plus G1 plus X0 minus M0 at P1. And in fact, what I should probably do is call this, it's not this, the level of consumption will have changed, so we can call this some level of consumption C1, because remember, if our equilibrium level of output changes, then our equilibrium level of consumption is going to change. Okay? And once again, when our level of output changes and when the price level changes, what happens? My level of consumption changes. So now I've got some level of consumption C2. I'm going to have some new equilibrium level of output, Y2, and some new equilibrium level of aggregate expenditure 2. Okay. Everyone happy with that? Yeah.
If P1 is greater than P0,
Sorry.
how come AE2 is
Yeah.
not below AE0?
It could be. If the change in P1 was such, right, that it totally, it changed aggregate expenditure to such an extent that the level of aggregate expenditure shifted to below where AE0 was, sure, that could happen, right? That's not usually the case. In other words, to answer your question with a diagram, right? If I had a situation where I'm plotting output against prices and I'm plotting aggregate demand against aggregate supply, and I shift my aggregate demand curve to the right, okay, so AD0, that was with some government spending G0, okay, and now I'm at AD1 with some level of government spending G1, okay, so that was the shift in the aggregate demand curve, right? This imbalance between the quantity supplied and the quantity demanded is going to lead to an increase in prices, right? Now, if I had some equilibrium level of output Y0 and I move to this new equilibrium level, y2, right? Are you happy that y2 is greater than y0? Right? You happy with that? In other words, that increase in government spending didn't increase prices so much that I ended up at some equilibrium level to the left of y0. Right? You with me? So, the same in our diagram here. That increase in government spending isn't now going to push me, isn't going to raise prices so high that I'm pushed back somewhere to the left of y0. You get what I'm saying? For that to occur, it would have to be the model wouldn't work, basically. It would never work in the model unless I had some kind of like downward sloping aggregate demand and a downward sloping aggregate supply curve, which, yeah, then the model doesn't work. Okay. Any other questions based on that? Okay. Let's take that break then. Take 10 minutes, and then we can come back and just get the chapter 25 stuff underway. If you have any questions, do come down and ask. Otherwise, 15:15, we'll start again.